Okay, moving on to problems 3 and 4. The instructions for these problems are still to solve each equation by factoring. If you remember, one key point of factoring is that it needs to be set equal to 0 in order to factor things. That's how the zero product property works. So in problem number 3, we actually want to move all of our terms to one side before we get started. So I'm going to add 28x to both sides, and I'm also going to add 48 to both sides to get everything on one side. So I'm going to have 4x squared plus 28x plus 48 equals 0. And we are going to solve this quadratic from this point. So we are factoring. Do you notice anything that all of these have in common right now? They're all currently divisible by 4. So let's factor out that 4, and we're going to end up with a trinomial that has a leading coefficient of 1. So if I take 4x squared and I factor out a 4, what is left? Just x squared. And if I take 28x and I factor out a 4, what's left? 7x. And what about if I take 48 and I factor out a 4? We're going to be left with 12. So I first factored out my greatest common factor from all of my terms here. Now that I've factored out my greatest common factor, this is the trinomial that I'm trying to factor. So luckily for us, this is a trinomial with a leading coefficient of 1. So we are looking for numbers that multiply to 12 and add to 7. I'm thinking 4 and 3. So because this leading coefficient of this trinomial is 1, I'm just going to drop this 4 from the outside down. And I'm going to put big brackets as to not confuse us as to what's going on. So this trinomial that I've highlighted in yellow, we can factor it using this 4 and 3 that we just wrote on the side. So we can write this as x plus 4 times x plus 3, and that equals 0. So factoring a trinomial with a leading coefficient of 1, once you figure out your terms in the x method, you can go straight to the factored form. All right, now that we're in our factored form, we want to set each factor equal to 0. So every single factor, so we have 3 factors here. The first one is 4 equals 0. The next one is x plus 4 equals 0. And the next one is x plus 3 equals 0. And we want to solve all of these for x. So looking at the one on the left that says 4 equals 0, is that a true statement? Does the number 4 equal the number 0? No, it does not. So we will just ignore that as a possibility because we know it is not possible. Let's look at our next factor. So the next factor is x plus 4 equals 0. If we want to solve that for x, we're going to subtract 4 from both sides to get x equals negative 4. And finally, to solve our last equation for x, we're going to subtract 3 from both sides to get x equals negative 3. So our answer for problem number 3, once we factor out our greatest common factor, is x equals negative 4 and x equals negative 3. Okay, moving on to our last factoring problem of the notes, we're going to look at problem number 4. So this problem, I'm having issues zooming in. Oh, what am I doing? No. Okay. For this problem, remember the steps that we just did in problem number 3. So the first thing we needed to do was we wanted to make sure that we have a quadratic trinomial on one side and it's set equal to 0. So this 12k, we're going to need to move to the other side. So let's first subtract 12k from both sides. So we're going to have 7k squared minus 12k plus 5 equals 0. So now that it's actually equal to 0, we can try to solve this by factoring. Notice that there is a number in front of the k squared. So to write the number in top of our x, we multiply 7 times 5 to get 35. And our middle term always goes on the bottom. So we're asking ourselves, what two numbers multiply to 35 and add to negative 12? I'm thinking a negative 5 and a negative 7 make a positive 35, but they make a negative 12. Now, because this has a leading coefficient other than 1, we need to rewrite this, just like we did in problem number 2, as 7k squared minus 5k minus 7k plus 5 equals 0. And now we want to factor by grouping. So we are going to look at our first two terms here. What do those terms have in common? They both have a k, right? So let's take out that k. What is left? We're going to have a 7k and a minus 5. Now let's look at our next set of terms. What do those have in common? They don't have anything in common, right? So we're going to factor out a 1. But keep in mind, we are trying to get the same thing inside both sets of parentheses. So if I don't factor anything out, I'm going to be writing a negative 7k plus 5 in this set of parentheses. But I would like it to be a positive 7k minus 5. So I'm actually going to factor out a negative 1 here. That's going to change all of my signs in my second set of parentheses so that these parentheses that are underlined in pink are identical. And that is what we need in order to factor. So that means we have 7k minus 5 times our outside numbers here, k minus 1 equals 0. If we want to solve this for k, that means we're going to set both terms equal to 0. So on the left-hand side, we have 7k minus 5 equals 0. To solve this for k, I'm first going to add 5 to both sides. So I have 7k equals 5. And then to get the k by itself, I'm going to divide by 7 to get k equals 5/7. So it is very possible to get fractions when you are solving quadratics by factoring. On the right-hand side, I'm going to add 1 to get k equals 1 as my answer. So we have two answers to this quadratic equation, k equals 5/7 or k equals 1.